Okay, here the problem is find the number of different arrangements of the 9 letters in the word activated. So 9 letters. If we see A is repeated twice over here, then C is once, then T is repeated twice, then I is once, then after I we have V, which is once, and I have E, it is again once, and D is once. Okay, so 2, 3, 5, 6, 7, 8, and 9. Okay, 9 letters. Find the number of different arrangements of the letter. So different arrangements will be 9 factorial divided by 2 factorial times 2 factorial. Okay, so 9 factorial divided by 2 factorial times 2 factorial. It is 9720. So the result is 9720. Now B part. Find the number of different arrangements of the 9 letter in the word activated in which there are at least 5 letters between two A's. At least 5 letters. So there could be 5 letter or 6 letter or 7 letter. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 letters. Now when there is 5 letters, so A could be here, then 1, 2, 3, 4, 5, and then A could be here. Then this A can shift here and here, and then A can shift here and here. So what I will say, that when we have a gap of 5, so I will say that with a gap of 5, with a gap of 5, the arrangement would be, now this A here in the first place I need not have to arrange, but the rest 7 letters I have to arrange. So that can be done in 7 factorial. Okay, that can be done in 7 factorial. The T is repeating twice, so I can say that 7 factorial divided by 2 factorial. 7 factorial divided by 2 factorial. Now this arrangement I seen that 3 times I can do. So with a gap of 5, this is 7 factorial divided by 2 factorial times 3. Similarly, with a gap of say 6. Now with a gap of 6, it will be 7 factorial divided by 2 factorial times. Now then two different arrangements I can have time 2. And last one I have a gap of 7. So with a gap of 7. So this arrangement will be 7 factorial divided by 2 factorial times 1. So therefore total arrangement I will say, therefore total arrangement will be 7 factorial divided by 2 factorial times, here it is 3 plus 2 plus 1. So this will be 15120. What we should do? Actually, we should calculate here itself. So it is 7560. This is 7560. If I see this is 5040, this is 5040, and if I see this is 2520. 2520. So the total arrangement here, if I see, it is 15,120. It is 15,120. Okay, 15,120 is the total arrangement. Now here third question. Find the letters. Five letters are selected at random from this nine-letter word. Find the probability that the selection does not contain more T's than A. So there will be more A's. So more A's will means there could be one A, okay, and no T, or there could be two A's. So we have different arrangements like here. Find the probability that the selection does not contain more T than A's. So A1 and T0 I will say. Then we have A2 and T0 and A2 and T1. And we can also have two A's are only there. So we have these three cases, right? We have these three cases. Let us understand once again. Five letters are selected at random from the nine-letter word. Find the probability that the selection does not contain more T's than A's. Few things I missed here. Does not contain more T's. That means here I have I can have 0A as well. Can I say that? Yeah, that is also possible. Na? So A0, T0, A1, T0 or A1, T1. Then I have A2, T0, A2, T1 and A2, T2. Okay. So first condition when I have no A, no T. Okay. So there are five letters. Now if I remove both A's and both T's, then out of nine, I have five letter only, and we have to select. Find the probability that the selection does not contain. So here, when I have no A and no T, so the total selection will be one, right? From five, I will choose all five. So this is one. When I choose one A, so that is and no T. So when I choose one A no T, that means from the remaining five, I have to choose four only. So that is five. If I choose one A and one T, then from the remaining, I have to choose three. Okay, so that can be done in 10 ways. If I choose two A's and no T, then again from the remaining five, I have to choose three. So that can be done in 10 ways. If I choose two A and one T, that means I have to select only two from the remaining, and that can be done in 10 ways. And if I select two A's and two T's, four. So only one, okay, I have to choose from the rest. Okay, so that will be done in five ways. Okay, so total arrangement if I see 10, 20, 30, 40, and 41. So this is 41. Now I think we are missing something over here. Find the probability that the selection does not contain Five letters are selected at random. Okay, have you identified any mistake here? Find the probability that the selection does not contain more T's than A. When there is no A, no T, I have to select from 5. I am choosing 5. When there is one A and no T, so then there are two A's, so I can select either of the two A. So here it should be 2 times 5C4, right? So this will become 10. It will be 10. Now when there is one A and one T, so here 2 times 2 times. Why 2 times 2 times? Because there are two A's, so I have two options of selecting A, and similarly I have two options of selecting T. So this will become 4040. If I'm selecting two A's and one T, no T, okay, so then it is 5C3 only. 5C3 is what 5C3 and 5C1 are same. So this is 5. This is 5 only. And when I select two A's and one T, so then again I have two choices. So 5C2 is 10. 10 times 2 is what? 20. And finally, again I have 5. So now this arrangement will change. Here 40, 50, 70, 80 and 81. So here we have total 81. Yeah, 5C3, it is 10, not 5. It's 10. So then it's 86. Okay. Find the probability that the selection does not contain more T's than A's. So therefore probability, the required probability will be 86 divided by, from now 9 I am selecting 5. So 95. So 86 divided by 9 C5 will be 86 divided by 126. So in reduced form, it can be written as 43 divided by 63, or in decimal form if you want, it can be written as 0.683. So this was a tough question. Okay, so these are the three parts. Find the probability that the selection does not contain more T's than A's. Okay, so you understand why we multiply by 2, 4, these numbers? Yes, because there are more choices. A1, T0, there I have two choices to select A, right? So therefore I include both of them.